tutors that are teaching that. I would like to point out to the forum of each software. So please, in case you have a question regarding specific software, please go there and ask a question there. And before asking, check the previous questions. Because one sophistic error was quite often, and I will show you how to solve it today again. But yeah, just remember that in the future, when working with other softwares, refer to the forum. And okay, let's start the second part of Sophistic. I hope you already downloaded the seminar material Sophistic under the folder second. Here we have the same Revit file, part 2 and 2 PDFs as previously. And yeah, the same goes here. You have 2 PDFs. One is very detailed tutorial part, which again goes into the detail with the screenshots and text. And there is a Sophistic 2 notes, again with its very compressed form, which we will follow today. So in case you fall behind, just go here and it's easy to catch up using it. Okay. And now let's open our Revit 2023. And a hack to open it without getting that Sophistic error is going into the models and open, and going into your main your downloaded files. You have to detach it from Central as a work sharing, and this basically allows you to edit anything in there. So we go through that. And we preserve the work sets. On the last tutorial, we learned how to set up the model, an analytical model in the Revit itself, in the Revit environment. So here we have a complete model with all the loads and all the boundary conditions and the node and the panels analytically. So we have everything set here already, so we don't have to do it and spend time on this. But again, if you missed the first tutorial and you don't know how to reach this point of the model, please refer to the first tutorial, because it basically, we talked there about at each load case, how to put it, and again, different hacks regarding it. And today we're going to explore Sophistic Analysis itself, which is a plugin into our Revit file, into our Revit environment, and we will utilize this tab, which allows us to actually export it and perform the analysis. And the main thing for us right now is basically linking Revit and Sophistic so it will understand what we are trying to give it. And the mapping is very important thing here, because sometimes in the Revit, again, you can have a custom material which have like specific settings, specific properties. Yeah, and again, to work on it, on the Sophistic Analysis, you have to firstly save it as your new model. For example, I will name it AK, it's my name. Okay, and now we can actually work on it, because you have to give it a path where it will save all the further results, and you can refer to them next time. So you have to save it and give the project path. Again, save as and just a project, and put your name of your file, of your path. And again, we go to the mapping and we go to materials. And here what I mean is that in the Revit material we can have a specific different materials, as for example here it's a specific DIN standard concrete, and same goes for other things, and we have to map it to our Sophistic material, which we will use in our analysis. So this is a reinforcement, for example, this is a specific number of the concrete. And you should check it in case, right now we all have set it up, but when you are modeling it itself, please check it, because sometimes, for example, it cannot be inside, and you have to edit it, and yeah, you can basically edit anything. The properties and the density, self-weight, because again, we have sometimes customized, for example, recycled materials, and we have different strengths and properties, so you have to just refer refer here, and it's quite self-explanatory again, where you can name it, and again, there is a different standard in case you have a special standard just going here. Okay, but because we have everything, we just go with it. And the same goes for the sections, because again, we can have a complex model, and in case we want to simplify it, we just give it a section in here, like 3020 is 2020 refers to just BH 2020. And you can also edit it in case it's not right in the beginning. So you can check anything you want here, like the reinforcement, the effective distance. Basically go into details of it. Yeah. Sorry. Okay. Yeah, it's just a short, an important thing is about the mapping. That again, I'm repeating it because some people didn't get it. The mapping is an important thing because sometimes you have a customized property of the Revit, and you have to map it into the sophistic, which will actually take specific properties of a material. Because again, for example, here we have a German standard of DIN, but here we have just the EN overall Eurocode, and basically it links it to the needed material. And again, you can edit it in case you have a different, for example, a recycled special material and it has different properties which are important for the analysis again. And also it's a hack in case you, in the future, you want to change a material of, for example, you want to upgrade the whole concrete in the model to C20, for example, 3037. So you can just do it from here. It's a bit faster way to change it. And it will basically read this information further. Okay, but again, we don't have it here. The same goes here, but it's basically this model was set up already taking into consideration the sophistic structure. So we don't have to change it. But again, it's a very important part. And again, we go to the sophistic project settings. It's one of the settings before the exporting of model. For example, this model was previously used, and I'm gonna give it a title. This project settings name basically gives us basically a new folder of the sophistic, which will be like an add-on file which will be created here, and all the results will be stored in there. So you give a title here. And in case you have a different, again, you want to start again the analysis with a different configuration of your model, you just change it and you give another name of the project. And here goes again all the overview. For example, here are some materials, and it highlights in case you have a material which is not used, but we don't need it right now, so it's all set up in here. It's like an overview again of everything, and you can play with it with a more complex. And one more thing, right now I cannot change it, this design code, because I transferred the standard and it has already the built-in German standard of Eurocode. But for example, in the worksheet that you will see, that you will be given just for your voluntary work, you can change the design code to the ones that you want. And the worksheet that I'm gonna release today is, this one is just voluntary if you would like to practice again all the workflows that we went through. And I'm asking just to utilize the Eurocode, not German one. So when you will be doing your model again, you should change the design code in here. But you can, we cannot change it right now because we limited the model in the beginning.
So at the end of the design, you cannot check our model for different standards?
Sorry?
Well, I know whenever we're done from the design or from the model, same as we have here, can't we test it in different codes? Because it is a common practice. Some countries use more than one standard.
Yeah, that's what I mean by the name, for example. That, for example, I can name it tutorial again 2023 as Eurocode, then, and I run the analysis, which I will explain you later, and it will save all the results in a special folder, which I name the path, and there will be another folder which will be the name after that. So you can go back to Revit after you finished your, for example, DIN analysis. You can change it to, I don't know, USA or Australia and just again rename it and again run the analysis.
But my question is for the design tool, since that it is locked.
Yeah. Right now it's locked, yeah, because it's intentional. But when you will try yourself with a worksheet, for example, because you will have like a complete free sheet. I'm asking you to use your previous file. It will be unlocked, so you can change it. Yeah. Right now it's locked because again we are following German standard right now, and we have the name of loads and actions completely to your code. Yeah. So I just save it like that and press OK. And now we are ready with our model when we check everything, and we press start. And a lot of people ask me, but you have to, in your finite element model, in the future, you have to give what kind of FEM you want to use. So basically, this is a window where you specify everything regarding your analysis. For example, the meshing, applying the loads, also the load case, which will carry the self weight of the structure. Right, for us is G1. The geometry. You can also give like if there's like weird things that are smaller than 0.1 meters squared, which will be omitted. And the same for meshing. If you would like to use triangular or quadrilateral, please refer here. And again, the refinement at edges is all in here. So we click calculate for the system generation. This basically generates us the FEM model, which will then look at it in a different environment. And okay, we see that it gives me, and probably to you, warning numbers 185. And to see it right now, what we can do is tick it and close it. And it will open us this big overview of all of our whole material, of our whole model. And here we can again check all the models and the material that we gave it. Here you can also check exactly what kind of graph follows the property of your, for example, concrete or any material. And we see here the warning, and it points out us to 102 and 104 load case, and it reads LC number 102, some free loads could not be completely covered, load near hole or edge, please check SOFI load, lower coordinate, and projection. This is, for example, one of the problems that you can face when you will be working with it, and how to solve it. Probably solving will be again from the scratch, that you have to check it. And usually if you created the model, you already know what kind of the loads are there. But let's check it, what are these loads? Okay, it's 102 and 104. And when we go back to Revit, you can still use the Revit itself because it's a different application of statistic report, and there is still Revit which you can use. So if we go to analyze, structural load case, analytical model and load cases, you can basically find what it means, these two models, two loads, which are problematic here, 102 and 104. So you find them. For example, I already know that they are here. That okay, this is 104. And why it gives us a problem? It's usually because there is a hole in the floor, and some of the loads probably are not covered by it. What we can do, there are different things that, again, that we can do. With this load, for example, I'm checking the boundaries, and I see that it's quite good, and I don't see any inconsistencies, and everything looks aligned to me. So I will just try, for example, making it a projected load, and it will basically be projected into the surface of this plane that is under it. And when you run here the Sophistic analysis start, yeah, you get this report, right? Yeah, you got this report, and you scroll down the analysis of load cases, and here you can see a yellow. Yeah, actually, yeah. And I just show you that in Analyze of the Revit you can find what exactly it is. And yeah, that means that probably you have to redraw or you have to check the boundary layer.
That's my question, like here you
Yeah. Yep. That's a problematic place of, I would say, the downside of the Revit, that you cannot really filter them out with the loading. So, for example, for me, I knew that this is a G2 and 102 and 104. So because for example, I worked with it before, I know that this is this one. But yeah, but yeah, that's one of the problems of the Revit which I faced with as well, because you cannot find sometimes it causes a problem that you just go from each one of them, and yeah, but you can filter actually only you can just filter the load. For example, in here. Okay. Well, you can filter them, but again, it depends on how you defined it. Because sometimes, for example, dead load can have two loads. But again, it may not work, but let's try again. But, okay, for example, variable load. And I will, for example, I'll untick them, and I will just, just a second. Annotation, analytical model categories, analytical structural load cases, and, for example, I untick everything except the Ferrandi-Hillas. But yeah, again, it depends on your model. I here have another cube. So in case, for example, there is a wind, you can open only the winds, but still you cannot specify which one of them. But yeah, now you can have it, for example, and you check it, and you check the boundaries of it, where exactly it has a problem. So, okay. This is a 104. This is 104, and yeah, I was trying to fix this one. Edit boundary, and you check the boundaries of it, where it actually may fail. For example, I see that I think it is. Yeah, you cannot. Yeah, that's why one of the downsides again is you have to mainly check. Yeah, you have to check it where exactly it fails. For example. And yeah, usually what could be a problem is the edges and the holes between them. So what I did before is I stepped a bit from the edge to make it more, to avoid the problem. For example, a bit that. Yeah, the boundary edges. Coordinates of what? Yeah, that's the load coordinates and projection. Again, it depends on all of your models, because sometimes it can be just solved with this projected load or orientation to the work plane. Yeah, right now it's flipped, and I just change the sign, and it will come back to it. And to check it again, for example, I fixed the 104, which I was thinking that it might be a problem. I can just go back to Sophistic analysis and run it again. Will we have a similar? Yeah. So this is a debugging of our sophistic, where you work and you try to find it. Okay, now we see that it gives us a problem. No. Just a second. I did not put back the visibility of other loads. And it should be in our model always. So we put them on back. And we run it. But I'm thinking that it probably will fail again. So let's check it.
So what are common issues that relax about it?
Yeah, that's okay. Oh, again, I did not click it. Close it. And yeah, we go back and we find the problem here. Yeah, we have a similar problem. So changing the boundary that did not work for us. So we have to go back again, and maybe it's a problem on the loads that are on the balconies. So this is a trial and error time where you change it and go back. So it takes a while, but yeah, this is one of the, again, the downside, which I personally don't like with the load casing. But with a proper, if you model the model, it's quite easy because you know that, oh, probably the hole is here, the hole is problematic, so I will again play with the boundaries, and with trial and error, I will get it. But for now, because again, we're just trying it, and I'm showing you where to debug it and where to find the error itself. We will just follow with what we have. I still keep in mind that I don't have this variable load on the balconies, so probably the strand that it will give me in the end probably is not completely correct. But again, you have to debug it so it will be completely right and completely exact. So now, no, because I have to go through each of the load cases. Yeah. Yeah. Because it's a hosted load. It's not an area. So I can pick a new host, and I can, the Q4. Yeah, I pick the new host, and I choose. And it disappeared. So that probably could be because of the different export. So what I can do, and actually it can solve the problem for me. It solved before that. Okay, let me make it clear again.
I'm just trying to understand how to solve it.
Yeah. Again, you can have a specific, for example, Q14. I can redo it, Q4, and as I remember, it should be Q104. And I remember that it was minus 2.3 exactly. So, or no, it was minus 5. Yeah. Yeah, to redefine them and go one by one and solve it with this problem. And again, check with your with the hosting of it. Right now, again, I kept all the errors, so I can show you this workflow of how can you go back and put it back, solve it. But again, I'm keeping it in mind, and probably ideally you have to solve it. But for now, for the sake of the project, again, I can go back, for example, to the output, and for sure it will give me the same problem because I didn't check all the load cases. Okay, yeah, and you have to check the visibilities to be sure that you have all the load cases. So if you put the filter before, please check it back, all your loads, and go ahead. Okay. The beams, yeah, and the holes. The holes are quite problematic the whole, because the meshing and the hosting may not work. Yeah, that's yeah. And again, the orientation and projected load. In case you want it projected, use a projected, and yeah, so it goes through back. Okay, now you have to go to Systems and SSD. This will open our structural desktop environment, and you have to choose a Sophistic building and press OK. And if you installed everything correctly, you will get this FEM application opened in another window. And here you can actually check the FEM models that we have created. And sometimes you can read that if you have a problem, that's one of the elements. Yeah, you just go. Because you did not, if it's grayed out, probably you did not install it correctly. You can check it here in the Sophistic Application Manager. Okay, I have to update it. But I specified the SSDs that you have to download. But the application model, it should be open. Yep. This start? This is a generation of our FEM. No, it checks the geometry, and for example the loads that it gave us, that probably one load is not completely covered, probably part of it is out of the FEM. So it can give us the structural geometry problems, but it didn't analyze it yet. That was probably checked with Sophistic AMG checking when we did it. Here we checked actually the coordination checks. So if you had any problems, it would probably appear here before. Yeah. Yeah. Okay. Thank you for pointing out. Yeah, we may add it. Yeah. It is industry. Yeah. I just showed you a small thing before about the adjustments of the analytical model. That again, if it gives a problem in the check, you can. Okay. Right now, you can adjust the analytical model. For example, it will detect a clash. And you go back, you can go and check and move the nodes, for example. Or the panel, if it's off, you can go and adjust it. Oh my, I can't do it right now, but for example, if I will hide the element. But yeah, you can just adjust it manually. But again, we have this assignment, worksheet that you can practice it. And in case if you have any problem, please let me know in the seminar Sophistic. That's why we give the worksheet, so you can go back against your whole workflow and check that you can actually use it for Eurocode, for example. And I also specify the location of Munich, so please apply the loads of snow and wind to the Munich location. So it will be more realistic analysis for you. Yeah. Yeah. Did you install? Oh. Did you have? Okay, this is specific. Okay, I wrote it in here. Which one you should download? Do you have Sophistic AMG? And do you have Sophistic Analysis? The Sophistic Analysis plus Design for Revit.
Yes.
And Sophistic FEA.
No, I don't have that.
So you have to download it.
I need FEA.
Yeah. Yeah, you have to have all these 3 packages so it will work. So yeah, in case you have this problem, check the installation again. Yeah.
There are some softwares that are independent FEA software. Can you not make something like we model it just from the FEA software rather than people from the Revit doing something like that? Because yourself, the Revit has some kind of like issues as well.
Yeah, that's a thing that here I'm talking about just utilizing the BIM model for preliminary analysis, for example. That you get a model from architect in Revit file, and here we aim to use these semantics that are coming from our Revit file to use it here. But
at the end of the day, are we getting those inputs like reinforced reverse and
yeah, we'll get it here because we have the design reinforced concrete, and we'll actually output our reinforcement. We get it here, and maybe then let's make a small, short 10-minute break till 12:15. So in case you don't have this SSD installed, please check it, and yeah, we will move on with actual analysis because right now we generated the FEM model. And yeah, feel free to ask me a question.